global trends and consumption. This is a bit of a long one. We'll talk about Canada, China, Brazil, and Japan. Now these case studies, they're going to be a little more brief than some of the presentations prior. First term, poverty. And there are two types. Absolute, meaning you're being deprived of food, water, medicine, housing. You'll see this in developing countries. Overall poverty is where you lack participation in the economy, and therefore you lack income or resources to sustain whatever livelihood you lead. You'll see this in developed countries. Now, poverty very much is a relative term, but the UN likes to say it's about $1.90 per day. And this has had to change due to things like inflation or purchasing power parity. Today, about 11% of the world population lives in poverty. That's 700 million people. And if you look at the map here, most of that is in sub-Saharan Africa and Southeast Asia. In fact, 80%. Now, the IB likes to say that women are more likely to live in poverty. But let's put some thought to this. First of all, women do enter different careers. They become nurses, teachers, and social workers more often than men. And if you look at the chart here, a lot of the jobs are innately lower paying. Therefore, there is no pay gap. Another reason? How about biology? Women become mothers, they have to nurture their children, and therefore take time off of work. This map here shows why women might not be making money, and that's because they're giving birth. Now, in the regions of Southeast Asia and Africa, this is prevalent because they're giving birth at an especially young age. Globalization really took off in the 1980s. Today, more than a quarter of all trade happens between developing countries, and as a result, natal policies have had to come into effect. Again, recall the three methods for that: regulation, incentives, and increasing the quality of life. That last one could be through healthcare, education, and technology. Now, you can abuse technology, and that's called resource endowment. That's where you're not taking advantage of the local labor supply, you're not giving people jobs because you have too much automation. Now, the global middle class has doubled in size between the years 2001 and 2011. It's expected to double again by the year 2050, and by then, about 60% of the global resource consumption will be in Asia. That leads us to some of the consequences of this growing middle class, and particularly how useful resources are becoming. This is dependent on culture and technology. For example, a place with lots of sand probably won't find it very useful unless they're building up their infrastructure and using that sand mixing with water to produce concrete, or maybe using that sand towards silicon and computer chips. Energy, another huge resource, comes in two types: renewables, where it regenerates faster than we're able to use it, or non-renewables, where we use it faster than it's able to regenerate. Now, renewables can become unsustainable if we flip that sign there and we start using it faster than we're able to regenerate it. Biocapacity, that is an ecosystem's ability to produce resources and consume waste all at the same time. We measure this in global hectares. It's about the size of a football field. An example here would be a forest. So it can be a carbon sink, that's where it consumes our waste, but it can also produce resources for us if we, say, chop those trees down and we use that towards paper. Now, our ecological footprint is constantly growing, but it's a number of footprints. It's our carbon footprint, it's our cropland footprint, and on average, this world has about 1.73 hectares available per person. Unfortunately, we use about 2.84 per capita on average. That means we need about 1.6 Earths to support our current demand. And considering that our ecological footprint is only growing, that's not a very bright future. There are different ways we measure sustainability by. The first one is strong. That's where you can only take resources and consume them. In weak sustainability, you can consume resources, but then you can produce new ones. And so you can almost turn natural capital into human capital and then back into natural capital. This makes our ecological footprint a lot smaller. An example of this: we've consumed a lot of coal in the past, but that allowed us to produce electricity, which allowed us to advance science and technology, which has allowed us to produce renewable energy. This is a map. The sizes of countries are morphed so that our ecological deficits can be compared. Now, if you look at China and the US, we have a third of their population. We're similarly sized because our ecological footprint per capita is a lot bigger. And in fact, we have an ecological deficit. We are unsustainable. How do we make up for this? We rely on trade imports. We have to import a lot of energy and food. Now, the US is an example of a debtor country, but Canada is a good example of a creditor country. And this is because they have an ecological surplus. Their biocapacity is greater than the footprint, they have more land, and fewer people. Per capita, they use about 7 hectares, but they have 15 at their disposal. Now, on a global scale, the amount of biocapacity we have is going down, but our ecological footprint per capita is going up. Some limitations of measuring our ecological footprint: 1. It assumes that the ocean is the only carbon sink. We know this is not true. Forests also help to absorb some of the carbon. It is inaccurate in rural countries. Maybe sometimes the data just isn't there. And our biocapacity excludes water. Speaking of water, water scarcity. That's when our need for water exceeds the availability. And there are 2 types. Physical, where the water just isn't there. For example, in Yemen, they rely on a lot of imported water, but because of the crisis and the surrounding wars, they're not able to access that. Then there's economic water scarcity, where it's being poorly managed. In India, farmers are quite slow to adapt. They're still growing crops that require a lot of water in arid regions, and their water consumption, 90% of that is accounted for by farming. Now, water is a renewable resource, but unfortunately, our water footprint is a lot greater than the biocapacity available, and that makes our consumption unsustainable. Now, countries can use less than the global average if they meet one of these 3 conditions. They have a low population density, they're not economically developed as much as some other countries, or they have an unsophisticated demand, and that leads us into virtual water, which I'll talk about later. There are 4 types of water. There's green water, that's what's being recycled between the atmosphere and agriculture. That's the moisture you find on plants. There's blue water, those are the reserves stored for humans. Gray water, that's wastewater. And black water is just wastewater with poop. Only about 2.5% of our global water supply is fresh water, and on the right hand side here you can see where a lot of that is sourced from. Now, a country's annual freshwater runoff is considered to be its internal resources. External meaning water that is imported, that's Japan, the UK, Mexico, and others. And about 10% of those internal resources are consumed directly by humans. Now, fresh water can come from below, otherwise known as base flow or groundwater. Some global trends here: as our population is increasing, our water demand is increasing even faster. We consume fresh water either intentionally, through agriculture, manufacturing, and domestic use, or unintentionally, where we lose it to evaporation, and that's through things like dams and reservoirs. Going back to virtual water, or otherwise known as embedded water, this is water that's used in the production, sale, or consumption of any goods. It doesn't have to physically be in the product. It's considered to be environmentally destructive when you import goods that have a lot of embedded water from countries that are in drought. And you're reducing the water supply for drinking when you use a lot of virtual water. Some trends in food production. As our population is increasing, the amount of land we're dedicating to food production is going up. This is enabling things like economies of scale, where we're able to grow enough that we're able to make food more affordable. We're increasing farm productivity. Spatial integration, that's the use of roads, trains, any sort of transportation that can move exports really easily, making commercial crops enticing for farmers. And international trade has helped to introduce new staple crops. Those staple crops are highly lucrative for farmers because it's all about income. Those include corn, wheat, soybean, rice, palm oil, and sunflower oil, things in high demand for energy and food. And unfortunately, we're abandoning some of the more diverse crops we should be consuming because they're becoming more expensive. I highlighted soybean, palm oil, and sunflower oil because these are especially energy dense and they contribute to a lot of the health issues we see today. On a global scale, diets are converging. They're becoming more similar to one another. The West is converging towards the East, and Asia is converging towards the West. This has increased the amount of calories, protein, and fat people have been consuming, and it's also helped to contribute to things like diabetes and growing rates of obesity. And because we're relying on only staple crops now, that's increasing our vulnerability to climate change because of things like blight. What happens if half of our food production is wiped out? Because of this converging diet, we're seeing a nutritional transition from what used to be pretty diverse to now diets that are heavily dependent on sugar, meat, and dairy. Because as incomes are rising, what was once previously unaffordable can now be afforded by more people. That includes a lot of Western food, and that's because the East has made a lot of trade links to the West. Brazil is a good example. And while obesity is not a good thing, it's a pretty good indicator of development. Obesity rates have been rising in Brazil, and this suggests some development in their country. China has used 800% more meat since 1975, and this has driven the price of grain up as they've had to import cattle grain. They've instated a reduced meat consumption plan, and this has the side effect of reducing emissions. Some trends in energy use: the use of biofuels has gone down and the use of fossil fuels has gone up. Looking at this map here, you'll see that a lot of the countries with higher indices of development are also ones that produce a lot of energy, and hydrocarbons are the bigger driver behind those wealth gaps we see today. A lot of these imbalances we see are solved by international trade. Countries are exporting and importing energy all the time. Obviously, there are going to be countries that need a lot more energy to be imported because they don't have the internal energy resources. One such example, Japan. They lack these internal energy resources. They have to import a lot of crude oil, natural gas, and nuclear materials. However, this doesn't make them poor. They're very rich. They're the number 2 exporter in the world of vehicles, and they're a huge exporter of computer parts. One other trend to identify in energy: countries which produce the most oil actually consume the least. Think Venezuela and a lot of the other OPEC countries. Then there's the idea of peak oil. It's the idea that in the near future, we'll reach some max oil extraction rate, followed by a decline. And this assumes that we have finite reserves. It's hard to determine because new technology is constantly being introduced and we can exploit new unconventional sources. This includes oil shale, natural gas. And the reason why we're constantly changing our predictions of when we'll reach peak oil is because oil barrel prices are constantly fluctuating. During the 1970s, when you had the OPEC crisis and barrel prices were crazy high, that made a lot of people think that we were going to reach peak oil. But we didn't. We're producing more oil than ever. And so the issue with peak oil is high prices of barrels of oil could either suggest low supply, which is where you have that peak oil, or high demand. Now, as oil prices have been going down, especially as of recently, this has made alternative energies less competitive. When we talk about oil, we're usually talking about conventional oil. It's cheap, that's why it dominates, it's prevalent, although it can be uncertain at times. It has a very high energy return on investment, or otherwise known as EROI. It has a low cost of extraction, and it comes from proven grounds, proven oil reserves. That means that when we go to a spot, there's a greater than 90% chance that we're going to be able to extract oil. Then there's unconventional oil. This is meant to supplant conventional oil and really just diversify where we get our energy. This has a lower EROI, pretty high cost of extraction, and typically it's sourced from unproven oil reserves. That means it's a less than 90% chance of extraction. And then there's coal. It has a pretty low EROI. It's low quality because it's not very energy dense, and we have to continually drill deeper in order to reach coal reserves. Nuclear energy, 2 types, the first of which is nuclear fission. It actually supplies about 14% of our global energy usage. It's less radioactive than coal. The dangerous part about it is the radioactive waste. And there's a public perception surrounding it. You'll hear about meltdowns all the time. Very high upfront cost, and there is a security risk. What happens when a country can suddenly refine uranium or plutonium so that they can create weapons. And then there's nuclear fusion, the future of nuclear. There are no byproducts except for helium, which is naturally produced. The supply would last millions of years, making it too regenerative for us to use it too fast. High EROI here. Large accidents are not plausible because the process takes place on too small of a scale. Unfortunately, with the current technology we have, we are not achieving the EROIs that are theoretically possible, and so at the moment it's not a viable source of energy. Biomass, that could be 3 different types here. The first of which is ethanol. It can be made out of corn, as it is in the US. It could also be made out of cane sugar. Unfortunately, this would compete with land that would otherwise be used for food production. There's firewood. This is very inefficient, low EROI here. And there's also human sewage, which is a creative use of it because you can turn it into farm fertilizer and therefore increase the agricultural productivity. So it's an energy resource for food. There is hydroelectricity, very high upfront cost, but cheap to maintain, and water's everywhere. You don't have to have fresh water. Unfortunately, they dam rivers and wildlife. there's siltation that occurs behind the dam and erosion below. And unfortunately, there's just the sheer force of water falling causes minuet but constant earthquakes. There's geothermal energy. Geothermal energy has a very small carbon footprint, a very small land footprint. It's renewable. You're relying on heat, and there's no fuel required. Unfortunately, it does produce some toxic gases, and because of the constant recycling of water, that water becomes more saline over time, which corrodes the plant. And, well, what happens when you have an earthquake or an eruption? There's wind energy. It's a renewable resource, and it helps farmers increase income. They can actually use some of their plots of land to sell energy back to the grid. Unfortunately, people argue that these wind turbines ruin the scenic beauty of landscapes, they're noisy, and they interfere with radio reception. Tidal energy. These can be located under existing bridges, and as tides become more volatile due to climate change, we'll actually be able to produce more energy. So it's funny how that works. Unfortunately, this hinders the migration of spawning fish, and it is quite expensive. On the contrary, solar is very cheap. The technology is constantly improving. Right now we're at 23% efficiency, and it's a renewable resource. Unfortunately, sunlight can be inconsistent, and some would argue that it's still too inefficient at the moment, and it requires a lot of land. Finally, there is an interesting resource, green crude algae. It's renewable, it's as performant as diesel, it's price competitive, and it doesn't need fresh water. Unfortunately, algae is quite sensitive. You have to have the right temperature, right amount of sunlight, and because of the current sizes of operations surrounding green crude algae production, there is an insufficient supply, and it is difficult to harvest when you have to separate the algae from the water. As always, don't forget to subscribe.